Good morning once again. All right, ready? It is Intro to Trig, Day 2. And so we got to talk about the basics, and we already gone over the homework, and so you remember the basics. If you're given a point that's on the terminal side of theta, then we can find all sorts of information. We can find out all the trig ratios, of what goes along with that. But now we're going to look at, there was a type of problem that we didn't get to that we're going to really see a lot of today, and this is where it kind of becomes a little bit more of a puzzle to figure out. And so we're going to dive right in. And with example numero uno, we see here that you're asked to find the remaining trig ratios of theta if sine theta is 1/3 and theta terminates in quadrant 2. Okay, and so we're kind of focused in on this part right here, the fact that sine theta is 1/3. All right, and I was talking with some students about a problem like this yesterday, and they said, well, okay, so if sine theta is 1/3, think about that. You know that sine theta is y over r. And so if sine theta is 1/3, I had a student say, well, that means that y is 1 and that r is 3. And that's sort of right, but that's not completely right. Because remember, we said that the input was always an angle and the output was always a ratio. And so 1/3 is just the ratio. 1/3 is the same thing as 9 over 27. Okay, and so that would be to say that y is 9 and r is 27. And so while we want to, these will work as, kind of substitution values, we want to make sure that we're not locked in that those are the only things that they could be, because the result of sine theta is a ratio. But what we're going to do is we're going to take those values. We're going to say, okay, so y, we're going to get that 1. And for r, we're going to use that 3. And that's a good start. And so then we know this idea of x squared plus y squared equals r squared. We plug everything in. We get x squared plus y squared, which is 1 squared, equals r squared, which is 3 squared. So therefore, x squared plus 1 is equal to 9. X squared is equal to 8. So x is equal to what at this point? And yesterday in class, I had a lot of people say, well, then it is equal to square root of 8, which is equal to 2 times the square root of 2. And then they rock and rolled everything, and they gave me what cosine theta was, tangent theta, cotangent, secant theta, and cosecant theta. And they got them all wrong, or they got a lot of them wrong. And the reason is they forgot the second piece of information. Theta terminates in quadrant 2. Okay, they forgot about that, and they did one little mathematical error. And that mathematical error happened right here. So what's wrong with that? Well, if you're at here, if you say that x squared is equal to 8, when you square root both sides, you should have x is equal to plus or minus the square root of 8, which is equal to plus or minus 2 times the square root of 2. And then you need to analyze the situation. Theta terminates in quadrant 2. Let's think about that. Okay, here's quadrant 1, here's quadrant 2, quadrant 3, quadrant 4. What's special about this quadrant? Well, one thing I know is that in terms of x and y, all the x's are negative and all the y's are positive. Now that makes sense because, see, we had a positive value for sine theta, and sine theta is dealing with y. So it would make sense that the y was positive. But this is saying that all of the x's should be negative. So when we find x, we need to deal with a negative square root of 8 and not a positive. That alone tells us which one we need. And so the actual value of x is negative square root of 8, or negative 2 times the square root of 2. That's the value of x, if these are the values of y and r. And so now at this point, we can find the remaining 5 trig ratios. Okay? We can't just assume that it's positive. R is always positive. Why is r always positive? Because it's a radius. Okay, but x and y can be negative, and a lot of times are, and we have to know when that's the case. All right, so what I'm going to do is try to get rid of a lot of this. Make this a little bit easier to put some other stuff here. Okay, and so now what I'm going to do is I'm going to write all the other trig ratios. And that should be pretty easy. We know that sine theta is 1/3. So therefore I go cosine theta, which is x over r. And so in this case, that's going to be negative 2 times the square root of 2 over 3. Tangent theta, which is y over x, is going to be 1 over the negative 2 times the square root of 2. Cotangent theta, which we switch it, is now x over y. So that's going to be negative 2 times the square root of 2 over 1, or just negative 2 times the square root of 2. Secant theta is going to be r over x, which in this case is going to be 3 over negative 2 times the square root of 2. And cosecant theta is r over y, which is going to be 3 over 1, which is just 3, okay? And so I want you to make sure that you understand what's going on in this problem. Every problem that we deal with that's going to be similar to this, if they don't give us x and y, if they give us what one of the trig function ratios is, then they will also tell us some other piece of information like this, like maybe where theta terminates, or maybe they'll give us something else that gives us an indication about some other value, whether it be positive or negative. And you need to be able to kind of do this. It's kind of like a little bit of a puzzle that you need to solve. So you got to take in all the information and make sure that you can figure out what's going on. Okay? All right. Well, now that you've seen that one, it's time for you to try it. So let's see what you can do. All right? What I want you to do is I want you to try this one. So we're going to pause the video and let you guys work. It might take about 5 or 6 minutes for you guys to do this, but let me make sure you read all of it. It says, find the remaining trig ratios of theta if cosine theta is 2/3, and this time theta terminates in quadrant 4. Okay? Find the remaining trig ratios of theta if cosine theta is 2/3 and theta terminates in quadrant 4. So you can pause the video right here, and I'll come back in just a minute and work through it after you guys are all done. All right. Hopefully you guys got it figured out. I think that this one is doable. Okay, we start with this idea of cosine theta is 2/3. Okay, and we think about, well, what does that mean? Well, we know that cosine theta is the ratio x over r. So if that's equal to 2/3, then we can kind of basically say, well, that's in the sense then x is equal to 2 for when r is 3. Okay, that's the ratio, the relative ratio of each other. All right, but then I got to do the x squared plus y squared equals r squared. So I get 4 plus y squared is equal to 9. So therefore y squared is 5 and y is equal to the plus or minus square root of 5. Super duper important. Plus or minus. Then we look at this other piece of information. Theta terminates in quadrant 4. 1, 2, 3, 4. Okay, so if theta terminates in quadrant 4, what's special about quadrant 4? Well, in terms of the x and y, x is positive and y is negative. And so again, I'm looking for y, so I'm looking for negative, not positive. So I know if x is 2 and r is 3, then y is negative square root of 5. Now, if you didn't get that right, then there's no chance that you got anything else right. But hopefully you did get that right. And then at this point, we just run through all those ratios because we know them pretty well by now. We say that sine theta is y over r. And so sine theta in this case is going to be negative square root of 5 over 3. Cosine theta, we were already given. What was that one? 2/3. Let's see here. Tangent theta, which is y over x. And so y is negative square root of 5. X is 2. Cotangent theta, we just flip that. It's x over y, so it's going to be 2 over the negative square root of 5. Secant theta, we just flip cosine, so that's going to be r over x, which is 3/2. And cosecant theta is equal to r over y, so we just flip sine theta, and we get 3 over negative square root of 5. All right, hopefully these are all the same answers that you got. Not too difficult. But like I said, a lot of these are almost like a puzzle. Like you're given a certain amount of information, you kind of got to figure out what's going on. Okay? All right, there's 2 kinds of problems left that we're going to take a quick look at, and these are all really easy. When I say easy, they don't have a lot of work. You just got to kind of think your way through them. Okay? And so let's talk about example numero dos. It says, indicate in which 2 quadrants theta must terminate so that the following statement is true. Okay? It says sine theta is negative 2/3. Now make sure you understand, we don't care about what this value is. We only care about this sign right here. We don't care that it's 2/3, we just care that it's negative. This is the biggest thing about this problem, is that we get that sine theta is negative. If sine theta is negative, we got to remember, what is sine? Well, sine theta is y over r. And r is a distance, so it can't be negative. So if sine theta is negative, that means that y is negative. And the question is, where on the coordinate plane, in which two quadrants, could theta be so that this is true? Well, y is negative everywhere down here. And so the answer would be, that would be quadrant 3 and quadrant 4. So if I was doing this, I don't have to draw this whole picture, but my answer would be quadrant 3 and quadrant 4. Okay? Next one. It says, now this one's definitely a little bit trickier. It says, okay, tangent theta is negative 4/5. Again, do not get hung up on what this value is. Your whole goal here is to see this. The fact that tangent theta is negative. Now, this is probably the trickiest one, okay? Because if you remember, tangent theta is y over x. So which one of those can be negative? The answer is both. So which one is negative? I don't know. What you have to think about is right here in quadrant 1, here when you're talking about x and y, they're both positive. So when you divide y over x, you get a positive. But over here in quadrant 2, x is negative and y is positive. So when you divide a negative by a positive, you would get a negative. And down here in quadrant 3, it would be a negative and a negative. When you divide a negative by a negative, it would be positive. And over here in quadrant 4, you have a positive and a negative. When you divide a negative by a positive, you're going to get a negative. So in this quadrant, everything's positive. In this quadrant, everything's positive. So if we're looking for tangent theta to be negative, then we want this quadrant and this quadrant down here. And what quadrants are those? That's quadrant 2 and quadrant 4. Okay? So tangent and cotangent are probably going to be your trickiest ones. All right, let's take a look at this last one. It says, okay, secant theta is negative. Again, I don't care about the 3/2 so much. I just care that secant theta is negative. And I got to remember what secant theta is. Secant theta is r over x. Remember, r cannot be negative. It's a length. It's the radius. So if something's negative, it's x. And we're told that secant theta is negative. So the only spots that that could be in is the two quadrants where x is negative, which is back over here. And so that would be quadrant 2 and quadrant 3. All right? And I don't need you to draw all these illustrations, but for every problem that you're asked to do like this, at the very least, you should write what's given to you in the book, okay? And you should write what quadrants you're dealing with. If you want to draw a picture, you're welcome to, but you don't have to, okay? Well, your turn. You guys give it a try. And these are going to be pretty quick. I think it'll take you maybe 2 or 3 minutes to get through all of them. But go ahead and give it a try. You can go ahead and pause the video right here and take a couple minutes and work through these. Ready? Go. Okay, let's see how you did. Hopefully you went through these and it made some sense. You got to remember, what is cosine theta? Cosine theta is x over r. R can't be negative, but x can be. And so for cosine theta to be negative, we're dealing with where x is negative, which is back over here. Okay? And so that would be quadrant 2 and quadrant 3. All right, for this next one, cotangent is negative. Remember, when cotangent's negative, that means that x and y have different signs. Okay? Because when they have the same sign, positive divided by a positive is positive, or a negative divided by a negative is positive. So they must have different signs, and that happens in quadrant 2 and quadrant 3. And lastly, let's see what we got going on here. We got cosecant theta is negative. And we're going to go, what is cosecant theta? Cosecant theta is r over y. So the only way that's going to be negative is for y to be negative. And that's everything down here. And so that would be quadrant 3 and quadrant 4. Okay, hopefully those match up with your answers. All right, here's what we're going to do. Here's the last thing we're going to look through today, and that is we're going to do one more example. I'm not going to have you try it, so I want to make sure you understand this example as we do it. Let's see here. I have somehow enacted my pen to... let's see if I can make this... All right, yeah. Sorry for just a second. I was worried that the pen was going to do crazy things. Auto minimize. There we go. Yep, it'll work. Okay, so last problem. This one, it says indicate which one quadrant theta must terminate so that this statement is true. Now this one, I really like these because what's happening is this is going to indicate two different quadrants and this is going to indicate two different quadrants, and your job is to see which quadrant do they overlap. I'm sorry, in which quadrant do they overlap, okay? And so let's take a look at this. If I talk about sine theta, okay, if I talk about sine theta being greater than 0, all right? Sine theta being greater than 0. Well, hopefully you remember by this point, sine theta is y over r. For sine theta to be greater than 0, that means it's positive, so that means y is positive. So that's everything up here. And then let's think about this. But then the second part says, but cosine theta is less than 0. Cosine theta is r over x. And for that to be negative, that would be where x is negative. And that would be everything back over here. So where do those two overlap? Right here. Quadrant 2. And so this is the kind of thing you can do. You're given two pieces of information and you have to find where they overlap. All right? So everybody take a look at this next one and see if you can kind of figure it out. It says tangent theta is greater than 0. What does that mean to say tangent theta is greater than 0? It would mean that tangent theta is positive. And cosecant theta is less than 0. So that is to say that cosecant theta is negative. Now we know that tangent theta is positive when they have the same signs. Because remember, tangent theta is y over x. So when you have the same signs, you're going to get positive. So that's positive here and positive here. But then we go, okay, cosecant theta, that's r over y. And we want that to be negative. Well, that's negative when y is negative. So that's everything right here. And clearly the overlap is right there. Quadrant 3. Okay, last one. Give you just a minute head start to take a look at it. We don't have to pause the video, but just look at secant theta being greater than 0. So what's secant theta? Secant theta is r over x. So for that to be positive, that would mean that x is positive. And cotangent theta is less than 0. And cotangent theta is x over y. For that to be negative, that means that they have to have different signs. Okay? So cotangent has a different sign here and here. That's what this one is. Okay? And then for secant theta to be greater than 0, that's x is greater than 0. That's everything right here. Okay? And clearly they overlap right there in quadrant 4. All right. I'm not going to have you try this one. I think that this was enough. You're going to do some on your homework right now and just work through this. Take your time. Try to make sure you fully understand this stuff because this is, there's no rush, but I need you, the next time I see you will be Monday, Tuesday. I need you to come in feeling pretty confident about all these things. You guys have a great weekend.